First of all, let's take a quick look at 5G and all its promises. It's a big step up from 4G. We're trying to do things with lower power. We're trying to get lower latency of network connections, trying to improve the reliability. Importantly, really, we're trying to improve the density of connections. So going from about 10,000 per square kilometre to about 1 million. So 2 orders of magnitude improvement. And we're trying to make it all go faster at the same time. So there's a lot of things going on. So how do we make all that happen, particularly the higher density of connections? Well, one way is to increase the number of base stations. So looking across history, we started with analog mobile phone system, then we went digital and we had GSM in Europe and CDMA in America. And then everybody aligned around 3G, UMTS, the Universal Mobile Telephone System. That then evolved into LTE 4G and now increasing the density further, going to 5G. However, to put these things closer together and make them more dense is expensive. We need more base stations. To make more base stations, we tend to make them smaller. And in order to keep the costs down, we do everything we can to get rid of connectors, including the 1 PPS test output that's traditionally used on a larger base station. Plus, we're trying to maximize the bandwidth, so that needs better optimization of the spectrum, which in turn needs good interference management, and that requires us to synchronize within the limits defined within the standards. Another change in the 5G is the elimination of guard bands between operators. Traditionally, within an operator, we would worry about interference, particularly at the cell edge, where the 2 cells come together and the RF signals will interfere. So one still needs to do RF over-the-air measurements, synchronization measurements on a cell-by-cell basis or within an operator. However, now we also need to measure the second operator as well. They too have a network, they will interfere themselves, and because of the elimination of the guard bands, 2 operators risk interfering at the frequency spectrum edges. So in order to get better coverage and provide good signals to the users, we often put cells in hard-to-reach places. And so the only way to measure this is to use an over-the-air measurement. How does the measurement work? We have a setup where we have GPS receiver disciplining a rubidium source to provide us a 1 PPS reference. This is our time reference. And then we have a digital receiver which receives the signal from the G node B, turns it into digital INQ samples. Those samples are time-stamped from the reference, and then the samples are processed to find the secondary and primary synchronization signals, from which we determine the cell ID, and from there we calculate the time to the start of frame and figure out the time error. So for more information, please visit our website at calnexsol.com.